Well, hi, good morning. Thank you so much for joining me in my shop here. It's July 30th. It's a beautiful day here. I shouldn't even say it because I know so many people are struggling with the weather. If it's not a forest fire smoke, it's super bad heat and stuff like that, or floods and torrential rain. But here, where I am today, it's fantastic. It's a cool, sunny day, and it's going to be that way for the next week or so. So very, very fortunate. I realize how fortunate I am. Okay, what are we going to do here today with this scope? So yesterday I messed around with it. I may not have operated it quite correctly, but nevertheless I did manage to find out it's largely working, but there seems to be some kind of, you could call it an intermittent problem, but that's not really what it is. It's something kind of loose, or something breaking down inside it. So I'm going to turn it back on here. It's plugged in a regular outlet, and we're going to just take a look at the action, or misaction, and then I plan to take the cover off, or take the insides out, depends how you look at it. Yeah, you can already see it's shaky. Look at that. Nothing's being banged or shooken or shaken, I guess is the word. And it's still doing it. Doing it right from the start. So the line length is changing here. And, kind of hints maybe it's a power supply problem. What kind of problem would you have in the power supply? A failing component? Cat, you might have a cat in the power supply. I thought you went outside. Excuse me while I speak with my cat for a minute. I thought you went outside. Didn't you go? You didn't go out? Yes? What? Okay, a cat of two eyes. I gotta stop already and let her go outside. I'll just leave this running in the meantime. But I don't think it's gonna settle down because it ran for quite a while yesterday and never stopped. Well, it turned out to be a good thing. I went upstairs to let the cat out because I discovered I hadn't turned on the coffee pot. Oh no. So it's bouncing up and down. It's varying in length. See them right now, except they're very small. Little pips occur. Doesn't seem to be quite as bad as it was. Oh, spoke too soon. Whoa! Is it my voice that's doing it? Okay, so the objective is to find out what that is. Now I'm going to try some wrapping of the machine here. I'm going to wrap on it and see what it does. I want a fairly sharp wrap, so I'm going to use this heavy mallet, very hard mallet. Okay, I saw that. Yeah, definitely. So this is optimistic actually, that I can find something in there that's a little loose. I'm going to just use this to hammer it back in place. Fantastic. Oops. Oop. Okay. Good. So, why don't we take the cabinet off now? A lot of instruments like this are designed to come out the front, so you can leave the cabinet in place and just pull the guts out forward. And doing that means you just have to access front screws. You can see there's a set of them all the way around. So it could be letting off these screws and the whole thing will come forward. Could be not. In the back here, again, there's a cover plate. We should take this off and see what's there. I'm curious about what is under this plate. Maybe a hand access to some adjustments on the CRT. That's my guess. These are probably settings for the operating voltage, the outlet voltage. A little dark in there. It is nameless. There is no indications here. There's a test point. So these might be test points. And perhaps you open these links or something during calibration activities, and maybe this is another test point. It could be a high voltage there. Doesn't quite look like it. I think they would cover it if it was. Okay, well that's not going to get us anywhere. Next two screws, I might as well do these ones here, which look like they could be holding the holding things together. Yeah, these are pretty long. Yeah. Whoops, longer than I expected. With a point, when they're pointed like that, that often means that you're trying to feed them into a hole somewhere. Plus there's also a cutter on it. Cutter hole. Right there. That's a little odd. Self-tapping would be the word for them. Lots of self-tapping screws in electronic work. And what they've really done is they've drilled the holes for the screws to go in the metal, but they haven't cut the thread. They know with the screw cut the thread. It's a time saver. Okay, is that enough already? I don't think so. There's two more screws right where my fingers are that you cannot see. There's two more screws right under here, which they. Yeah, it's not gonna come out. And I'll bet you I got to do all those front screws too. I wouldn't be surprised. Well, wait a minute. We have a manual here. Sometimes they have a screw diagram in the manual. Schematic parts list, circuit description, references, calibration. No, I don't think they do. Circuit description. It's a small book. I don't know if they're going to take any time to tell you about a few screws. A small book like that. Oh, this is a different size. Different size. Okay, so if we go back to the front, I'm going to leave those in just now. They have a different, they're pointing upwards. You can almost see through here. I could if I had my flashlight. Somebody give me my flashlight. Appears to be missing in action. I'm sure it's catching the bottom of the chassis down there. Why would they use different size screws? That's a little odd. I doubt I have the right. We have a flat piece there. Let me take a look. No, oh. They don't look right. They don't look right. Let me just grab the other camera here. And they don't look right. Looks like it's missing a washer. So you can see the hole, a bit of a slot there, I think. Why would they put in a different size screw? And these screws, they have a slot on them. What about the ones at the front? Well, for crying out loud there, Phillips. For crying out loud. All different screws. Oops, I had the wrong camera going there. Okay, so yeah, I just looked to the front, and these screws are Phillips screws, different screws. Well, what could these front screws be doing if they're not holding it in? What would this be? So you may just be holding the front panel onto the frame of the chassis. Somehow I don't think so. I think it would be kind of loosey-goosey. The whole front, the whole insides. I think I got to take these out. I think I got to take them out. Okay, I'm gonna do that. I'll use this. Okay, I'll do it off camera here. Yeah, I took a couple screws out and then realized if these screws are holding the guts to the frame, then I won't be able to move the frame relative to the front here. Just putting a little bit of pressure. Seems solid to me, so I'm sure those screws got to come out. Come out they will. Okay, there's still two more here which are suspiciously look like they should come out too, but I'm not going to take them out until I'm a little more convinced of that. How do we get something big like this out of a big case like that? First, you just got to get a little movement happening. So probably I'm just going to wedge against here. See if I can move it. And the answer is no. So I'm going to take these two lower screws out. Now I've got my, that looks like a quarter. Quarter is too big. I can get away with a quarter. These feel like I've got imperial tools on a metric screw. That's what that felt like. Well, I'll be. It's the same style self-tapper. Behave. There we go. Okay, there's only two screws left in it now. There's two at the front. There it goes. Okay, we figured out how to do this. Good thing I left those two in at the front because they're probably holding some parts in. See the panel. Sure enough, there's a piece that screws into right here. Okay, this is a big guy. What's the best way to do this? It's pretty big. Probably if I turn it this way and try to pull this out. Now, some of these devices, when they're unscrewed from the cabinet, they're either shaped okay, like the frame is okay, you can just put them on the bench. Others have a foot that sticks down the back to hold things up, so you can put it on the bench and there isn't going to be a problem. Don't know what to expect with this, of course. Probably it just sit right on the bench. What I'm worried about is if I'm going to pull it out, it's going to drop down because there's nothing back here. But that can't be the case. I'm worried about nothing. Oh boy, oh boy. I didn't eat my Wheaties this morning. Here we go. Oh, it's full of tubes. This is really intended for repairing vacuum tube TVs. That's what they envisioned with it. Okay, now there could be some pretty high voltage stored away in here. I want to grab the wrong thing. Okay, there's a weird looking transformer hanging down there. That's what it's sitting on right now. Not the best. But okay, nothing special in the cabinet. This is too big to go on my spinner, unless I leave it on this transformer. You might say, what in heaven's name have they done with the transformer? Look at it. It's all cockeyed down there. That's got to be on purpose. And that has to be some kind of trying to accommodate a problem with the magnetic field developed around here. Hum or something like that. You keep it away from the top. How come this is all crushed in like this? That doesn't look normal. Okay, let's look at it from front to back. So there's quite a few things here that, any one of these tubes could have been causing that effect. Look at that. That's a bug. I just took a little yucky bug out of there. A lot of these test wires here, they're just kind of running right up to the CRT. This could even be alternate inputs, but I don't remember reading anything about them in the manual. Okay, we come along this way. There's chips and bits of wood in here that look like wood. So oil stain or some kind of liquid leaking in this area. We have a part here which appears to have been replaced. You can tell it's up on stilts, solder, the angle, it's off the board. This looks like it's been replaced. Let's come a little closer. A lot of these vacuum tubes, a lot of these scopes will have 25 vacuum tubes in it. Not this one. I have 3 here. I'm looking down underneath. You can't see yet. Look at that more closely. So, of course, they're going to put the tubes up on top because they want the heat to leave. The heat doesn't go up. Hot air goes up. So that's why they put these up on the top. So the hot air will leave. Didn't see anything else kind of obvious. Any one of these tubes could be causing that effect because of just being in the socket loose, or requires a reseating of it. Big filter capacitors here. These are probably high voltage guys. They're located in the back here, kind of by themselves, kind of close to the CRT. Some of these are hooked up to these terminals. Okay, come around this way. You see 1, 2, 3 compactrons. I have a few of those in a box somewhere. It's kind of a crummy way of doing this. There's some just bare wires here. Just coming. That's pretty crummy. Why would they ever do that? Why wouldn't they use an insulated wire here? Like these two are almost touching. They're going to 3 different places. That's kind of odd. They've done the same thing over on this side. There's another bare wire just where you could have used an insulated wire. Cheap. Man, they're cheap. Okay, the same thing goes for all these controls. They can have dirt in them, although it didn't seem to be the case. They could be the cause of the shakiness. So I think the name of the game at this point is to operate the set with a stick, tap it. Now, there is dangerous high voltage in this. There's dangerous high voltages in all tube equipment. But this one is pretty unforgiving, and that's I want to locate where the positive connection is made to here. There should be a connector. There usually is a connector up on the side. I don't see one. Well, then I guess in this case the high voltage gets to the tube. Must come through one of these pins. If you look at the back of this, you can see these two heavily insulated, kind of heavy wires. These are almost certainly coming from that power transformer just to run the heater. And we have some more here that are well insulated going up. And then we have these lighter, kind of like belt telephone, I would call them, type wires, mostly going to this panel. One of those would be a high voltage one. High voltage on a thing like this, I honestly don't really know. Would be, I don't know, 5,000, 10,000 volts maybe. What I'm talking about is the voltage that's on the front of the screen. On the inside, that's the high positive voltage to draw the electrons to the front of the screen from way back here, where they're being emitted. Look, any weird parts in here? Anything I look at and go, what is that thing? I don't really see that. There's adjustments down here. Down here. Which you can only get at when this is out of its cabinet. A whole whack of adjustments here. And we need to look underneath. There's a component that's put in with a twist tie. That's a little odd. Can we lay this on its side? Probably. Everything should be well supported. So I'm going to tip this on its side. I don't think there'll be a problem. Unless I contact some high voltage while I'm doing it. Okay. See the transformer and its unusual mounting on this angle. Large capacitors here. B and K they're labeled. I didn't know B and K made components. 15 microfarads. I'm trying to read the voltage. 1600, does it say there? 1600 volts. Yikes, don't touch those. Don't touch anything. Look at this great big one here. It's got a little bit of goop coming out of it. Right there. So, gold. These two resistors that are gold banded resistors. So high quality stuff. Usually these things are built, equipment like this is usually really well built. So they won't have trouble. So they can go into a service shop and work trouble free for years and years. Okay, so what's the story with this now? This is not what you would do in the factory. This is not a factory thing. Somebody's come in here and managed to replace this one. Why wouldn't they strap it back with the original strapping, or the original way it was held in place? It looks original though, doesn't it? It's the right kind. There's a lot of these. Who made that? It says B&K on it. So, it's possible this thing went back to the B&K factory for a tune-up, and they may have done a couple things. One is tuned it up. The other one is they may have made circuit improvements that they had discovered along the way while they were manufacturing this. So one comes back in the shop. It was an early one out of the factory. They put the later changes into it, bring it up to date, so to speak. That's what this could be. I don't know. Just taking wild guesses here. Wild guesses. What's down under here? Another great big white capacitor. Well, it's a good thing, these type of devices are very likely to work, by the way. Again, because they're built with high quality parts, and built in a way which is supposed to make them operate trouble-free for a long, long time, because their reputation depends on it. If these things get into trouble in a shop, the shop can't work. The shop can't work, can't make money. It's a money loser if this thing causes trouble. If they were to buy something like this and a year later they start having repeated trouble with it, they would stop buying B&K equipment. Because they just can't tolerate the trouble. So that means these things are usually very well built, For instance, the resistors are probably not pushed hard in it and stuff like that. Here's the relay that we heard snapping, and I believe this relay is operating the outlet here. How can it operate this outlet? There's a yellow wire here, goes right to the relay, right to the outlet. And so that's the turn on a light because an intermittent was discovered by the machine. Well, that's about it for looking at it. I think what we got to do is turn it on and start sticking it and try to find where the sensitive spot is in it. And hopefully it's just one. A lot of stuff to poke at here. Holy smokes. We have to keep an eye on the screen the whole time to spot it. Okay, well, I'm going to go and get some coffee and take a little break, and then we're going to start whacking it with a stick. That'll learn it. I may have mentioned, or I did mention a few videos ago, that I'm trying to teach myself how to drum, and that's going really poorly. But I've got a stick here. This is like a drumstick. I'm going to warn this guy right now. If he doesn't come around, I'm getting the real drumsticks, and I'm coming in here to practice on them. Do you hear that? There we go. I've plugged it back into my isolation transformer, but I have not put the power on yet. There we go. Put it in the isolation transformer because I may be contacting it with my hands, even accidentally or unknowingly, and I'm just better off to have it in. I mean, it is a 3-pronged plug. I'm sure this would remain grounded, but let's do this. At least I can even contact voltages in here that are would be something relative to ground, but because this is plugged into an isolation transformer, it's no longer relative to ground. Ground has no role. So there we see the effect. First thing I'm going to do is wiggle tubes. Okay, so I'm just going to start this one. Oh my gosh. Oh, what's a cat doing in here again? Well, I just happened to pick the right tube. Can you see? You can't see which tube I'm poking at. Well, come over here and have a look. You can still see the screen. I just touched this one. It goes wild. Well, maybe they're all like this. Oh my gosh, here's another one. Or am I flexing something in the board? No, it's got to be the tubes. Okay, that's enough of that. We're going to turn it off, cool off for a bit, let the charges deplete in it. I'm going to pull out each tube and reseat them. And that'll be the first attempt at getting rid of the intermittent problem. Meanwhile, oh my gosh, look who's back. Who's come back? Ah, you went outside, but then you came in. You came in on your own. You don't remember. She's thinking hard. So I think cats run in two modes. One is their emotional, natural mode. They hunt with, they react with everything with that. But once in a while you can bring them right up into consciousness like us. Like she's kind of getting there now. They look you right in the eye and they seem quite conscious. But I think inside their heads, their thinking is something like this. I want to go outside. Hey, what's that? That's what I think is going on inside a cat's head. Once they're up to their highest level of consciousness. Okay, come on, cat, we're going. I'm going to let you outside. Thought I'd let you see my advanced pin and socket cleaning technique. There it is. So I said that you don't want to make one of these machines with some kind of problem exactly like this in it. Jim, your hand is right on the chassis. Your other hand is right on the outside of the picture tube. Or the CRT. Somehow I didn't get a shock. No more tubes there. Down underneath there's none. Could be some other plug-in items. Okay, so there's a tube back here. This kind of looks like a rectifier tube. It's a big tall one. I said something about could be the power supply, but see, if you have a power supply with a intermittent load on it, the load is coming and going. Well, that effect can be cast through the whole machine. So you'd find it everywhere if you went looking for it. Okay, what about those little, let me stand this up again. What is good to hold on to? Everything is good. It's all strong. Okay, up you go. Okay, got one guy here. This guy looks like a big rectifier. A lot of cooling fins inside there. Continental. What value? 6BA4. What? 6BA4. 6CA4. Okay, never heard of that tube. Well, that's the other side of buying or having this kind of equipment, is it can have parts in it, especially tubes, that are not common. See, look at this board. First, there's debris all over it. All kinds of little bits of debris. Where would that have come from? It's all in here, too. Almost looks like wood chips. Like sawdust. It could have been somebody's garage for a while and got sawdusted. And these tubes are, let me just get a little cloth here. I'd like your tubes to be shiny. These are, you know, as the tube era came to an end, the tube makers were going wild, coming up with ways to entice designers to continue using tubes. So this is locked in or something? Wow, it's not coming out. Okay, you don't want to come out. I moved it around anyway. So these tubes, these can be 2 and 3 different things inside one tube shell. It has more pins. They changed the size. They call these a compactron because they're a little bit more compact. Okay. Is there anything else here that should be? I should do that. Maybe right with the picture tube, or the CRT. I guess you can call this a. Well, you can't call it a picture tube. There's no picture. Now, the high voltage could be sitting here. Could be sitting here. Oh, this is really on. Okay, we're going to leave that. We're going to leave that alone. It's really. It'll take a little effort to get that off. So we'll find out. Let's just carry on. Carry on. Okay, we'll leave it standing up like this now, and. On it. See if it's become stable. Maybe it's stabilized. You have to hope a little bit that did it. Oh! I was feeling pretty good there for a minute. Notice it didn't really show up until kind of late in the game. We already had high voltage on the screen because we could see the line. There was high voltage in the set. But then, the way she went. Okay. Come back down here. Okay, so generally, how sensitive is this thing to being knocked around? That's why I like using a light mass stick. I don't see anything happening. Okay, we'll go down this side. Tubes. This tube? Oh boy. Or something in the area of that tube? nothing really over here. It's pretty stable now. It was this one here that I moved. Oh, look at that. Intermittent problem. How do you clear that again? Do that. There we go. What about this part that they put in? Ho-ah! Ooh-ha-ha! Oh, ho-ho. My other cat. This one. Watch this. I haven't touched it yet. Here we go. I'm touching it. There's something going on there. Gold solder joint or something going on here. But first, I have another visitor this morning. This guy. Peanut. Peanut. What do you want? There, see, I got him sort of conscious there. And you can see, I'm insulting you, cat. Hey, never mind that. Pay attention. Focus. Oh, what's he doing? Peanut, up here. What's that? That's outside? That's about all you're going to get out of him. Okay, got to leave this guy alone again. Head up and this guy being the scope. Leave the scope alone again and go deal with the cat, right? He's licking himself again. Surprisingly, he did not want to go out. He just wanted more food in his bowl. So, this thing is as stable now as can be. Okay, let's see if we can disturb it. First the tube. Just touching it ever so slightly. This component. Just checking some neutral things. What if I touch something that shouldn't, I'm not suspicious of? This one over here. Back to the tube. Back to this guy. Okay, so I'm going to flex it a bit now. You can't see what I'm doing. I'm just applying very gentle pressure. So it looks like this thing's doing something. Funny, it's replaced. Funny, haha. It appears to be replaced. Could be how it's soldered underneath the board. I don't know what they did here. Somebody did that. That's not a factory thing. Back to this tube. Okay, so, whoa, okay, intermittent problem. Let's shut it off. Pull this tube out again. Oh, guess what? It's hot. Who'd have thought? And that's a problem. The tube's getting hot. I don't see anything unusual. Unusual sockets. Those would be high quality sockets probably. Okay, what tube is this? This is a... Pins are hot. Pins are hot. Wow. Normally have the pins get that hot. Hotter than the glass. Phew. This is a hot guy. It looks like 66, no, maybe 6GH8. So yeah, 6GH8. I think I've heard of that too. Sylvania. This is something else. This is the same something else. There's a story developing here. It's a Dyna something. Don't know what that is. I'm looking to see if these are the same make, or have these been replaced over the life of the instrument. We could take a wild guess now that this Sylvania is a replacement tube, because the earlier tube failed, and when it failed, maybe it shorted, and it took this guy out. and so they had to replace that. That's an adjustable resistor with 3 legs. Is it really? 600 ohms, 10%. And I'm sure there's an adjusting screw here. Okay, can we see? Let's look at it more closely. Yes. Always look at things closely. Now I'm going to take a minute here. I'm going to stop the automatic focus from doing its thing, so just bear with me. I've done this 1,000 times on my video. Take direct control over the focus of the camera. We're going to zoom it in quite a bit. Okay, let's go see what we got here. It almost looks like that one piece of solder right here is cracked. I don't know how it would crack. Well, somebody did a good shot at soldering this. Can we see anything if I... Oh! It's hot here. Interesting enough, the back of my finger is much more sensitive than the pad. And maybe it's because of the thinness of the skin there or something. That's just a little warm. What is it? 0.47. Gotta be a capacitor. That's the coffee time warning. Okay, I'm going to wiggle this a little bit. Let me steady up the camera. Anything doing funny stuff. This is really quite rigid. I'm wiggling it with my thumb, my finger. That's really, really rigid. So if there's trouble, it's going to be underneath. Tube more closely. Not that I expect to see anything here. Over the years I've found very little trouble with pin contact on tubes, except maybe initially. If you just pull them out and stick them in or wiggle them around like I was doing, it pretty much resolves it every time. I don't see anything obvious about anything. So tubes that run hot, especially I've already noticed that this one, whoops, let me switch cameras so you don't have to look at that. Heat obviously can get down into the pins, down through the pins into the socket. In fact, that may be part of the heat sink for the tube. And the heat is then drawn down into the socket and right down into the socket terminals, which are soldered. And every time you turn it on and off, everything heats up, cools down. And if it's quite hot enough, you can get a little chemistry starting to happen in solder and things like that. And ultimately you end up with a bad connection. That felt nice. Should we look up underneath? Let's look up underneath here. Okay. Again, making sure that's good. Good grabbage. Here. There we go. Yeah, I'll use this camera again. Here. Just a little more lighting. Like about so. Okay, so the socket will be a circle of... There it is. That's circle. Yes, that's definitely it. There's some parts in the way here. Can I come in like this? What am I looking for anyway? I'm looking to see... Let's come up this way. Well, the tube terminals are in the back. In the, I haven't got the camera in close enough yet. Pushing it in here. Wow. They look lovely. Okay, let me wiggle the tube a little bit. Anything moving here? The whole board is flexing. Nothing appears loose. I'm looking at each terminal one at a time. Okay, but you know what? You could have something that's just not visible. So just, resoldering this stuff may find a problem. Now the bottom of this guy, this thing here, it's way up in a tough spot. Okay, I'm going to wiggle it a bit. See any terminals moving? You can see the 3 terminals that are involved. You can kind of see the board is going up and down, pulsing, bump, 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 bump. A little wee bit. That's just flexing the whole board. Well, again, maybe just resoldering this stuff. Resistor looks like it's had a rough life. Or it's none of the stuff I'm looking at. It's something else in the area. Okay, let's do this. Now, I've been outside quite a few times already today, and it's just fantastic. What am I doing in here? I should be outside. Okay, I've put the tube back in. Everything is just as it was. We'll switch this guy on. Is it stable? Remember, it was stable at first, and then it got wonky. You can watch all the different voltages building up. That looks pretty good. That's what I said last time, and then it went. Okay, can we find it now? No wonder that tube is hot. Can you see the heater in here is just glowing like a light bulb? Well, not like a light bulb, but it's in the orange range for sure. Okay, we're going to stick a few things now because see how stable it is? I see how stable it is. Okay, first of all, the mallet on the frame test. Okay, well, you can expect something to happen. That's not what it was, though, was it? Is it? Was it? Is it? It's not nearly what was going on. Okay, we're going to tap the tube. It's still not happy. The line is jumping down, jumping up. As if there's moments of well, let's see. Let me just try moving it. Yikes. Okay, now that other control, the supposed resistor, and try moving it. Okay, and a component nearby, try moving it. So no action on the nearby component, really. But on the resistor, that thing on the legs, wait, stop. Not terribly sensitive. Okay, so this controls right in the area. Is this guy part of the picture? No. This tube back here. Am I being fooled? I'm tapping something. I'm only tapping one thing. You need to tap many things. Yeah, for sure. This tube is still acting up. It's possible the tube itself has trouble. That's a little scary because if the internal parts are loose or shifting, they can end up where you don't want them. And they can end up doing a short, almost certainly would. So I'm just moving the tube around a little bit. So it looks like a tube socket problem here, because look at it go wild. Oh, that scares me every time that happens. It indicated the intermittent. Maybe that's part of this function is in that tube. Well, I think the next stage is, we could take it out and put it in a few more times. See if that doesn't fix it up. I'm just switch it off here. Or it's resoldering. Or it's time for coffee. Time for coffee. Okay, let's do the soldering here. Hard to see. Of course, I've pulled the tube out. It's one. This is going to be a little boring of the video, I think. Yeah, I think I'm going to turn it off here. You see what I'm doing. Just melting off every one of the terminals on the tube here. Yeah, I'll just carry on my own. Okay, let's see if that did it. Power's on. There we go. And of course I've put the tube back in the socket. I only did the tube. I left that resistor alone. I don't want to do two things at once. I'm not really capable of doing two things at once. That looks nice and stable. I think I've said that a few times now. Looks like it has a bit of a hum in it. What if I set the sweep to line? Steady, very steady. Just leave it alone. I claim I fixed it. I hate to do this, but I must tap it. Okay, I'm tapping the tube. Much better. Still showing. Okay, I'm going to wiggle it here. I hate to do this, put my finger on it. Still some contact issues there. The next thing would be to spray a little bit of cleaner right in the tube socket. Look at that, I got it to go again. Is it the tube for sure? What about this resistor? Every time I tap that resistor I get a... Okay, I'm going to push on the resistor here. Oh! Okay, we're going to resolder that too. Is it possible both of them are acting up? Well, yeah, of course it's possible. This and many other things are in trouble in here. I don't think so. But the curious thing is they're right close together, physically in the radio, or in the scope. So these ones are way up here. Got the solder. Scope is off. with the far one. Right up in the corner. Okay, that melted. And then this one. Now, the thing about doing this, melting the solder, is you stand a good chance of introducing a problem while you think you're solving it. Okay, you don't need any extra solder. Those 3 are done underneath there. So, not to be too surprised if the situation actually goes downhill. What it would say is you're in the right zone. Just not quite doing the right thing. Okay, power on, power on. This scope has a nice big screen on it. This is a big screen. When I look at it with my eyes, this is dark green, and this doesn't look particularly bright. Looks right, but woo! But on the camera, it looks like it's overdone. That's the problem with trying to video a light source. Okay, so still unstable. First 2. Hey, nothing's happening unless I really wiggle it. Resistor, not digging a dog. Fingers and whoa, scared the living daylights out of me. Grab it with my fingers. Yeah, there's something definitely wrong with this. So we'll try the upper terminals this time. These are the terminals right on the bottom of the component, which look so wonderfully soldered that I'm going to get in there and mess them up. Or the component itself may be in some kind of trouble. And you know what I'm going to do? I'm going to put on my, I'll get a good look at this. I'm going to put on my magnifier here, these things. Now I'm going to get right in front of the camera maybe. Am I getting in front of the camera? Not quite. Okay, soldering iron. So are these lap joints? They look like they're lap joints, which means they just held the wires side by side and then soldered them. They're not pinched. It's not a pinched connection. I think that makes it more of a target for being that one didn't look terribly good. I'm not sure what you can see. I can't look up right now. So if you're seeing the back of my hand, sorry about that. Okay, so I've resoldered those. Let's see what happens. So there's leads that go inside of this little box. And what goes on inside this box? Well, they're going to connect to something else in some way. Either a mechanical connection or solder, or who knows how they've done it. The problem could be inside, is what I'm getting at. Okay, we're all set to go again. Here we go. So there's supposed to be 2 lights coming on. Yeah, the light over here is not coming on. Change that light bulb at some point. Interesting. They've actually, it's not really in a regular light bulb socket. They've actually soldered the wire to the bottom of the light bulb. How stable are you? You don't look too good. Look like you're wandering around now. Why are you wandering like that? Okay, let's touch this thing. Oh my gosh, he's in bad shape. I'm touching the resistor body. Okay, so there is a adjustment on the end of it, what I think is an adjustment. Let's take a look with the other camera. Let's see, what was that? Something just fell down? No, something getting tangled up in the camera cord. Okay, so we want to look at the end of this thing. It's on, set's on, Jim. Oh yeah, big screwdriver thing. So you can assume that this is a variable resistor. Probably adjusted as part of the process of aligning the set, aligning the scope. And so there's going to be some kind of, some kind of contact inside there. So if I turn this a little bit, I'm going to flex the whole thing unfortunately, but if I turn this just a little bit, what's it do? Oh, it just goes nuts. Okay, so my options now are to spray some cleaner inside this thing, or just do what I'm doing. I'm just wiggling it. Look at it settle down. Okay, I'm going to go a little further. Wow. Now, how would you spray cleaner in this? But I think I'm getting to the meat of the issue here. Oops. Ah. Slipped off. That's what I'm doing. And okay, how stable are you now, my friend? Look at that. Kind of using a drumming technique there. Not really. Okay, I'm gonna flex it. Well, the flexing doesn't do anything anymore. So I think it's an internal matter inside that control. So we can spray it with some stuff. Let me turn this set off. I'll just keep calling it a set. I have some stuff. Now, where would you spray it? Let's get that other camera and take a look. Is spraying this stuff a good thing to do? Well, I don't know. Can we spray it past that knob? Oh, it doesn't really look like it. What about these holes? Where do these holes go? Oh, those are mounting holes. If you were to mount it. Well, this thing's going to be sealed otherwise. There's not going to be a port. How about a hole with an arrow pointing to it? Spray here. I don't think I'm going to find that. So the only hope, whoops, where'd it go? The only hope is to spray it around this thing and somehow hope some of it will go inside. That's a fat chance on that. What are the chances that I have one of these? The chances are extremely low that I have that part. What are the chances I have something else that would go in there, even a fixed resistors, as opposed to that? Hey, that's quite possible. Okay, so we're going to give this a try for what it's worth. It's probably worth nothing. The set is off. So I'm going to remember where it is, where the setting is. Spray right on here. This isn't going to do anything. Ooh, spray everywhere. Okay, don't lose the screwdriver. Stuff is running down the side of the CRT. It's sprayed everywhere. So I'm hoping some of it is somehow going in and somehow traveling down far enough. You know, give it enough time, this stuff might flow in there. It's on the right angle. What do I do about the mess I made here? I suppose it doesn't really matter. I mean, this stuff is meant to be sprayed on electronic stuff, so put that wire back up there. Is it this loose wire that's causing stuff too? I gotta shake that wire. Okay, ready again. There we go. Then at some point, you know, there's always a risk that while you're doing this, you actually end up destroying the part you're trying to fix. This thing already shows an intermittent. The intermittent light didn't go out when I switched it back to balance. This is stuck on. That's all bad news. Why would that be the case? Because I rotated the control so far, not meaning to, but I did. Where did the screwdriver go? What do I do with it? Get another one. I rotated that control so far that it's messed up the machine. Go ahead and tap it. Okay, so the fluid didn't really do anything. Push on it. Pushing on it kind of indicates the wire leads and stuff. Tapping on it can be both the leads and the stuff inside. Okay, so I'm going to turn this adjustment. Wow. I think this is the bad actor, though. Because you wouldn't expect it to jump and pop like that. You'd expect it to do something smooth and pleasant. Something enjoyable. I can't get the screwdriver in. There we go. Okay, so we know this problem. Every time whatever it's doing, it's going open inside or something. I guess that's about all it can do, really. Is go open briefly. It would be from dirt on the track. And I have turned this thing a long ways now. You know what? I did turn it a long ways before, so I've probably in a situation now where I have to follow the calibration instructions to restore this properly. Fortunately, I have them. If I didn't have them, I'd be a lot more careful. Okay, but just sitting here, it's no longer doing its intermittent nonsense, and we will go back to what we started with. Look at that. And what about that wire? No, that wire's not doing anything. There we are. I think I got it. And that fluid may penetrate further over time. I'll give it a little wiggle a little while from now. Let's see, this is stuck on intermittent because I'm pretty sure when you set this to balance, this should give up. And it's not. It is on, isn't it? Or is that just light coming through? Watch where you stick your hand. Well, use something else. It's just light coming through. Well, that's probably why this thing has a case. Yeah. Okay, I think that's pretty good, actually. Yeah, I think I succeeded. We know where the problem is if it reoccurs. Fantastic. Well, that's it for today. Tomorrow we'll look more closely at calibration. We'll see how accurate this thing is, and we'll get involved with what's involved in doing a calibration. We'll look at trying to set that resistor that I've monkeyed around with, and see if we can't get it back. At the very least, see if we can't get that back into good stead. Good stead. Okay. Well, thanks a lot for watching. And so this is. Did I mention this? This is one component of a 4-component test bench. The other 3 components will come in here one at a time. And it's all about CB radio. Yeah, CB radio. The radio that won't go away. Okay, we'll see you later. And by the way, thanks for the super thanks. See ya.